Thank you very much, and hope there's a room for a little bit more information in your brains at this late hour. I'm with the Independent Evaluation Group. We're independent. We report directly to the Board of Directors of the World Bank Group, and our job is one both of accountability and learning. We look at what the bank group does, down from the level of individual projects to the level of broad sectors or themes, and try to find out what's working, what's not working, and why. So we're 2/3 of the way through a series looking at the bank's efforts related to climate change. I'd like to talk to you about just some elements of the report we just issued on climate change mitigation. It's available on our website. It covers a wide range of issues because they are so diverse and varied. But I'll just pick out about 4 issues to talk about, and I want to dwell on the problem of how we get information for impact assessment. Here I'm looking at the impact of these projects, these activities on development and on climate change mitigation. And we'll talk about 4 areas: deforestation, clean energy, carbon finance, and the role of feedback and learning in improving all these things. So let's start with what's been one of the bank's main efforts in the area of forestry, which has been the creation and maintenance of protected areas. You heard this morning the loss of forests, primarily tropical forests, accounts for about 15% of all the greenhouse gas emissions in the world. So most of that comes from the tropical forests. Protected areas were created largely to protect biodiversity, but to the extent that they keep people from tearing down forests, they will reduce carbon emissions. But there's controversy about the impact of protected areas. A lot of people view them as just paper parks. They're just meaningless lines on the landscape. They don't do anything. Other people say, no, they work all too well. They're exclusionary. They keep local people from access to resources. So to try to get a handle on what at least the environmental impacts were, we used GIS methods, such as the ones we've heard about before. And we looked at the set of the world's tropical protected areas. Here we see a protected area in Rondônia in Brazil. You can see, I don't know if you can actually see it, but these are the outlines of the park. You can see that inside the park there's lots of forest. Outside the park it's been chopped up into farmland. The red dots we've superimposed where forest fires occur. It looks like the park is working. And up till now, a lot of the impact analysis has been compare what's going on inside the park, what's outside the park. That's the impact of protecting the forest. But this simple, naive inside-outside comparison can lead you astray. Here's another protected area in Indonesia. Again, we've got the boundary of the park, lots of forests inside the park, lots of farms outside the park. Looks like the park is working. But on the other hand, if you notice, we've exaggerated the elevation here. The park is all mountains. And maybe it's not that the park is protecting the forest, maybe the park is there because no one wants to climb up in those mountains and turn it into farmland. So this is actually a very profound problem in analyzing impact and getting proper treatment and controls. We used matching methods. We took a sample of points in all the tropical protected areas in the world. And here we tried to match each point with a point outside a protected area with the same characteristics. So here you see 2 characteristics. We've got rainfall and distance remoteness. These are important determinants of deforestation. If we just compare the protected areas with the unprotected areas, they don't have the same characteristics. So we match them and find sets of points that are matched on these and other characteristics, and use this as our basis for comparison. And when we do this, we find that strictly protected areas are in fact not just paper parks. They do reduce deforestation by about 2 to 4 percentage points over 8 years. But surprisingly, and this surprised a lot of people, the parks that are not exclusionary, the parks that allow sustainable use by local people, are on average more effective than the strictly protected areas. And the indigenous areas are virtually off the chart in how effective they are in protecting against deforestation. So we think this will be important information to guide the current efforts at forest protection as part of the global climate regime. Next, let's look at the energy investments. The bank, the IFC, have extensive investments in clean energy. Sorry, keep hitting the machine. We want to know what the impacts of these investments are on saving carbon emissions and on producing economic benefits. But we run into some problems. First of all, we have an evaluation cycle at the bank and at the IFC, which is very rigid. At the bank, evaluation occurs at the moment when the project closes, which is an arbitrary moment in the life cycle of a project. For an energy efficiency project, it may have been running for many years when it closes. For a hydroelectric plant, they may have just finished pouring the concrete when the project closes. IFC, similarly, it occurs after 5 years. And even when the project has officially been closed and evaluated, the procedures for documenting what its impacts are not providing the kind of information we want, even on economic impacts, let alone on carbon impacts. So we've had to cobble together a set of inconsistent data, often relying on appraisal data. But this will, I think, illustrate the way we would like to go if information were better. And I think it's already possible to draw some broad conclusions. So what we've done here is we've taken a bunch of renewable energy efficiency projects. We've classified them on 2 dimensions. Here is the economic rate of return, the strict economic rate of return, purely counting domestic benefits, no global benefits, just domestic benefits. And here is it has a mind of its own. On the bottom axis is the carbon rate of return, the kilograms of carbon lifetime saved per dollar of investment. Here are wind projects in light blue, hydro projects darker blue. Transmission and distribution projects have very attractive rates of return and save some carbon. But now, I'm sorry, this thing is out of my control. What I'm going to do is I'm going to imagine pulling the camera back. We're going to zoom back and see a wider range of projects with higher rates of return. So this first square shrinks down. We zoom further, and further still. And now we see over here projects that involve efficient lighting, that involve industrial energy efficiency, whose economic rates of return are well above 100%. They dwarf in economic terms virtually every other development project that the bank group does, and they return carbon benefits. So we're calling for greater attention to the benefits of energy efficiency. I want to speak briefly about carbon finance. The World Bank has played an important role in developing the institutional mechanism for carbon projects under the Clean Development Mechanism. The original idea of carbon projects is that they would, by rewarding the investor for the global benefits of saving carbon, they'd shift the balance in favor of doing these projects, which otherwise might not be economically attractive. So we wanted to see if that was actually true. We took a bunch of projects. We computed their return to the investor with and without the carbon benefits. And what we found is that the carbon benefits were relatively modest. Here's the return before carbon, return after carbon. Very little impact on, say, boosting your return from below a 15% threshold to above a 15% threshold. Basically, only a modest effect on changing incentives, and no impact really on solving the investor's big problem, which is the need for upfront finance for these complicated projects. So this is a feature of the low current price of carbon. Things might be very different if carbon were priced at $30 or $40 instead of $10, but we can find other things that right now have greater impact. So let me come back to this issue of the need for better information and more timely information. The problems with these 8 or 10 year evaluation cycles that I mentioned. One of the good things about CDM projects, having now told you some of the disadvantages of CDM projects, there is one remarkable thing about these projects which should attract the attention of the people here who do impact assessment, which is that carbon projects, by definition, are the commodity you're buying is basically an impact evaluation. What you're buying is an evaluation of the impact of the project on carbon emissions. And even though we kind of question the baseline in many cases, one of the great things about these projects is that you have to monitor their actual output. You have to report it publicly every year. This sets these projects apart from virtually all other projects that we do. Here's one example of why that's valuable. When CDM projects began to be popular around about 2000, people realized that it was going to be very attractive to do methane capture from landfill facilities. This is the exception to my rule of my conclusion about the lack of impact of carbon finance. You get 25 times the payment for a ton of methane as you do for a ton of CO2. So for these kinds of projects, carbon finance can make them very attractive. So a whole bunch of these projects went into production. But within 2 or 3 years, because of the requirement for public reporting, it became clear that these projects were not performing as designed. They were only returning 5 or 10% of the methane production that they were supposed to produce. So the World Bank, to its credit, hired some engineers. They convened some workshops to try to figure out what was going on. And one of the answers was that these projects were being designed using engineering models based on U.S. garbage. And developing country garbage is different from U.S. garbage. It has a different moisture content. It degrades, it decays at a different rate. Also, developing country landfills are operated in different ways from U.S. landfills. They have more people on them, for one thing. So with this information, it's been possible to improve both the design and the operation of these projects. And what we see is that there's a huge need for this kind of rapid feedback across the board in so many of the areas that we're working on in climate. We need to have better information on the relative returns of the projects that I mentioned earlier. We need to understand much better what are the actual behavioral barriers to energy efficiency, whose promise seems so great. We need to know better how to substitute social safety nets for energy subsidies, which are very inefficient ways to protect poor people from high prices. We need to know much better how far other forest interventions, such as community forestry, works. And we need to understand why many hydropower plants and wind power plants are performing beneath their design parameters. So with billions of dollars at stake, with the CO2 concentration in the atmosphere rising year by year, we really can't afford to be slow at this. We need much more rapid feedback and better information. Thank you very much.